AI will not take your job. If you believe the internet, it's already over. AI has killed programming. Engineers are obsolete and all the jobs are gone. But I just want you to think about something for a second. When cars were invented, it was the greatest leap in technology. Going from a horse to a car, and people being people, thought another leap was inbound, and flying cars were right around the corner. And fast forward decades later, and we are still stuck in traffic with no signs of using flying cars. And there's a ton of other examples of something like this, where a new technology drops, people overhype it and say it's going to get 20 times better and replace the systems that we currently have. And if that sounds familiar, it's because AI is no different. So if it gives you any peace of mind, I just want you to know that as a computer science student, AI is not going to replace you. But with that said, you need to ensure that you don't ignore AI, because engineers who learn how to use it will be moving 10 times faster than the ones who don't. But like I always say, this doesn't mean to outsource your entire brain. If you treat AI like a crutch, you will eventually stop learning how to code, and you will become the person who can type prompts but can't actually solve any problem. And companies are hiring professional prompters. They're hiring engineers who can think, who knows when AI helps and when it hurts. So keep thinking for yourself, keep working hard, and keep learning to code. Because the real question isn't, will AI replace programmers? The real question is, when it comes down to hiring, who do you think wins? The engineer who can code and use AI as a tool, or the one who only knows how to code? Or even worse, the only one who knows how to prompt an AI. Most students treat computer science like homework. They study just enough to pass. They build projects only because someone told them. It looks good on a resume. And sure, these things might get you through that class and give you decent credibility. But the second things get hard, do students quit? And the way to avoid this is to find a way to romanticize the process, to make the grind feel exciting instead of exhausting. And in order to actually do that, you need to stop measuring yourself only by outcomes and start doing things for yourself. So code a game you always wanted to make, or build a tool that you would actually use. Forget all the noise and just create something that excites you, because if you are always doing work that you only see as a code and code for the resume, then you will never actually enjoy it. If you mix in project that you care about, you will naturally code more, and you will start to associate coding with curiosity, not just stress. But also, romanticizing the process doesn't mean it's always going to be fun. You're buying for iris, you're chroming deck your ideas for your program, or reading documentation. All of these aren't fun. But if you have built that connection to why you are coding in the first place, because it's yours and because you choose it, even the frustration parts feel more like they matter, and also make it a lot less likely for you to quit. So that's how the grind becomes addictive instead of draining. And here's the truth, computer science never really ends. There's always a new language or a new tool or a new problem or a new subject that you don't know. And you can see that as an endless stress or an endless opportunity. If you learn to love the process itself, the process of learning and not knowing things, you won't burn out. You'll actually start looking forward to it. And so does the real cheat code. Most students are just going to quit when coding stops being fun or stops exciting them, or even when it just gets slightly too hard. But the ones who stay and the ones who are actually going to succeed in this job market are the ones who fall in love with the grind. You don't need huge giant projects. For a lot of students, that's just a trap, because most students think they need to build the next Facebook or a massive end-to-end app to stand out. But there's the reality. What matters is whenever you can build and deploy something that people actually use, and that's where small projects win. For example, a script with 10 to 20 stars on GitHub, if not more impressive than a giant unfinished app just rooting on your laptop. And that's because the stars prove that someone outside of you found your project useful. And oftentimes that's a lot harder to do than just coding something on your machine. And the best part is most projects are finishable. You don't need 6 months of planning. You just need to solve one problem well enough for people to care. For example, it could be a script that auto-applies to jobs, and then you can share it on Reddit and get a few users. Or you can code a small browser extension that fixes an annoying problem that you always have. Or maybe even a command line tool that saves you 5 minutes every day. And these aren't huge ideas, but they are real and finished and able to be used by other people. And that's the difference. Most students waste a ton of time trying to create a really big projects, and don't get me wrong, these are impressive, but most students can't actually stick to it and end up wasting time in the long run. So if you want to avoid that, try making smaller, useful things really well. Basically, I think everyone who gets good at coding goes through a learning pyramid where each layer builds on the one below it. Take web dev, for example. At the bottom, you have got your basics, HTML, CSS, JavaScript. And once you have that done, you move up to frameworks like React or Vue or whatever. And then above that, you're hitting all the backend stuff like APIs and databases. Then comes deployment and scaling and cloud infrastructure. And at the top, you have actual systems that hold up in the real world. Now here's why this matters. When you see someone way ahead of you working at your dream job, it's not because we're smarter by any means. We're just simply climbed higher on their pyramid. And if you want to get there too, you can't just skip steps or copy and paste your way up. You have to build each layer properly. So if you're wondering when you should use AI, basically the higher that you climb, the more AI becomes your accelerator instead of your crutch. If you use it at the bottom before you understand the fundamentals, you're just cheating yourself. You're just letting autocomplete do your thinking. But once you have actually mastered a layer, there's no problem with using AI to complete the tedious beats that you found on this part of the pyramid. Basically, it can turn all the grunt work into shortcuts. Nail the basics first and then let AI multiply what you already know, because the stronger your foundation, the faster you can climb and the less that AI will ever hold you back. The other cool thing about this pyramid analogy is that it kind of gives you a roadmap. If you know what your end goal is, like I want to be a web developer, then you can literally sketch out your pyramid. Think, what's the foundation? What are the middle layers? What's the peak? And suddenly, getting better at coding feels less value and more like you just need to master certain topics in order to reach your end goal. Thank you for watching my video, and I hope we can all get to where we want to be someday.